हेलो स्टूडेंट्स। तो आज का जो लेक्चर हम कवर कर रहे हैं उसमें है कंडक्शन, मोलर कंडक्शन एंड कोहराश लॉ एंड एप्लीकेशंस। बहुत ही इंपॉर्टेंट है जेई और नीट पॉइंट ऑफ व्यू से, तो इसको करना बहुत ज़रूरी है। जैसे नस्ट इक्वेशन बहुत इंपॉर्टेंट है इलेक्ट्रो में, सिमिलरली कोहराश लॉ और उसके एप्लीकेशन से भी बहुत सारे क्वेश्चन आते हैं इंक्लूडिंग द मोलर कंडक्टेंस एंड कंडक्टेंस। सो बेस्ट ऑफ लक, enjoy the lecture. So next segment we have a conductor. Conductor means which can allow the current pass through the electron and ions. So first one we have a metallic, another is electrolytes. Electrolytes can be aqueous and molten. Here the charge carried by the electron means electron are responsible for conduction of electricity, और यहाँ पे ions are responsible for conduction of electricity. No chemical change during the process. Here also, here electrolytes will get decomposed. No transfer of mass, and here the transfer of mass. In that case, resistance is happened due to the collision. So when the temperature increases, resistance will increase. And here when the temperature is increasing, resistance will decrease. So metallic considered to be the better conductor compared to the electrolytes. They are the better conductor. Now we have a few general terms. One is called resistance. तो चलो समझते हैं रेजिस्टेंस क्या होता है। तो रेजिस्टेंस बेसिकली मेटालिक और इलेक्ट्रोलिटिक कंडक्टर विच ओबेज द ओम्स लॉ। तो ओम्स लॉ के अकॉर्डिंगली वी नो दैट आर वुड बी इज इक्वल टू वी बाय आई, वेयर वी इज अ पोटेंशियल डिफरेंस and I is a current, and the unit should be the ohm. Now next is reciprocal of this is called conductance, represented by G. Conductance is a reciprocal of the resistance, so G would be equal to 1 upon R. इसको हम लिख सकते हैं ओम इनवर्स और एल्स मो और एल्स साइमंस, represented by S. Then after that we have resistivity. So resistivity opposite, I'll write the specific conductance, represented by the special symbol that is called the kappa. Now specific resistance kappa is reciprocal of the resistivity. So we know that R would be is equal to rho L by A. L is considered as a length of the this is the length between the two electrodes, and A is a cross section area of these electrodes. So we will write here 1 by R L by A. So the unit we can write ohm centimeter inverse, that is 1 upon R, so ohm inverse, and this is the centimeter inverse, length is centimeter, area is centimeter square. Or else we could write the Simon centimeter inverse. So we can write the kappa should be is equal to 1 upon R is a conductance, and L by A is considered to be the sigma, where sigma is L by A, named as cell constant. Unit is centimeter inverse or maybe the meter inverse. So specific conductance or conductivity we will consider as a same terminology. So here suppose if you have a two electrode which is held by the battery, then this is the length between them and this is the area of cross section present in electrolytes. Here the conductivity of the solution or specific conductance kappa is depend on number of ions per unit volume. So it's very obvious, if the volume you increase, number of ions will decreases per unit volume, so the specific conductivity or conductance is gonna be decreases. So kappa is directly proportional to the number of ions per liter, or else inversely proportional to the volume. If the volume of the electrolyte increases, then kappa will be decreases. Conductance is an additive quantity also. So if the solute is contain 3 different electrolytes, then the conductance will be equal to G1, G2 and G3. So the specific conductance kappa would be equal to K1 plus K2 plus K3, means kappa of the each electrolyte. So factor influence the conductivity of electrolyte. The first one is a interionic interaction. If the force of attraction between the solute particle is higher, it's very obvious they cannot move easily, and if the movement is not happening, conduction is not good. So if the interaction is higher, conduction will be lower. Second, polarity of the solvent. So if the solvent is greatly polarized, then the ionization take place and the conduction will be more. So higher the polarity, higher the conduction, or maybe the kappa is also higher. Viscosity is a resistance to flow. So if the viscosity is higher, conduction will be lower. And temperature. So temperature of electrolytes increase the movement of ions. And the fifth number is dilution. So specific conductance decreases with increased dilution because number of ions per unit volume is decreasing. So dilution increasing, kappa gonna be decreases. Now this conductivity we can classify into two categories. One is called molar conductivity, which is represented by the delta M, and other is called equivalent conductivity, represented by delta EQ. So basically molar conductivity means that 1 mole of electrolyte responsible for conduction in V liter of solution. तो जितने ज़्यादा नंबर ऑफ आयन्स होंगे इलेक्ट्रोलाइट्स के, दैट 1 मोल ऑफ इलेक्ट्रोलाइट्स प्रेजेंट है V लीटर ऑफ सॉल्यूशन, वो उसकी मोलर कंडक्टिविटी कहलाएगी. तो मोलर कंडक्टिविटी इज डायरेक्टली प्रोपोर्शनल टू द वॉल्यूम ऑफ सॉल्यूशन इन लीटर. So it's a conductivity power of all the ions present in solution having 1 mole of electrolytes. So it's directly proportional to V. When I remove this, it will convert into the kappa and the volume in liter. So molarity, we know that moles by V, but the moles is 1 mole, so molarity would be equal to 1 by V. So we will write the molar conductivity would be equal to kappa into 1 by M, where M is moles per liter and kappa is a Siemens centimeter inverse. So we will write the kappa divide by molarity. Moles per liter means we will write the 10 to the power 3 centimeter square or centimeter cube moles, and that should be Siemens centimeter inverse. And if we are converting, that molar conductivity would be equal to kappa Siemens meter square, then we will write that 1 upon molarity, moles per liter, 10 to the power minus 3 meter cube moles. So we will get the kappa 10 to the power 3 into molarity. Here the unit is Siemens meter square mole. Equivalent conductivity, we can say the conducting ability of one equivalent of the electrolytes taken in V liter of solution. So here the molar conductivity means equivalent conductivity. So equivalent conductivity means it's just a 1 mole we can replace by the 1 equivalent moles of electrolytes in V liter of solution responsible for conduction. So here the equivalent conductivity would be is equal to kappa into 1000 by normality. Here the unit should be, instead of moles, we will write the equivalent moles. So it becomes Siemens meter square equivalent moles. And it could be the kappa by 10 to the power 3 into normality, Siemens meter square equivalent moles. So when we talk about the relation between the molar conductivity to the equivalent conductivity, so molar conductivity would be equal to kappa into 1000 by molarity, and equivalent conductivity would be equal to kappa into 1000 by normality. So we can divide this and we can get it normality by molarity. Normality is molarity into n factor by molarity. This is gonna be cancelled. So we will get it, the molar conductivity would be equal to equivalent conductivity into n factor. Now next point we have, that is called the effect of dilution on the molar conductivity or equivalent conductivity also. So like molar conductivity is directly proportional to the volume of solution in liter. So when it is increasing, molar conductivity is also increasing. So we could say when the dilution is higher, molar conductivity or equivalent conductivity is also higher. So when we say the strong electrolyte, how the strong electrolyte's conduction is gonna be increased? When you increase the volume, that force of attraction between the ions decreases. So obviously the movement will be increase. Movement of ion increases. But when we talk about the weak electrolytes, so when you increase the volume, the degree of dissociation is also gonna be increases. So in that case, we can say the conduction is increasing in both the cases when you increase the dilution. But if you keep doing the infinite dilution, then definitely this is not valid, because number of ions per unit volume is gonna be decreases. So we could say the molar conductivity is directly proportional to the concentration of the electrolytes. When it is higher, the molar conductivity is also higher. So we can say the molar conductivity is actually kappa into 1000 by molarity. So when the molarity is higher, that molar conductivity or kappa will be increases when the molarity will be higher, because number of ions per unit volume is higher, but the molar conductivity gonna be decreases, because in the total volume number of ions will be less. So molar conductivity means the conductance is furnished by 1 mole of electrolytes only. So when the concentration is approaching to the 0, so molar conductivity is considered to be the limiting molar conductivity. So it's represented by delta M naught. So we could say that at infinite dilution, ionization of the weak electrolytes we are considering, it's 100%. So here we have one scientist, that is called the Huckel-on-Sager equation. He has given one equation which is valid for the strong electrolyte, that molar conductivity would be is equal to molar conductivity at infinite dilution minus B root C, only for strong electrolyte. So this is the molar conductivity at C concentration, and this is the molar conductivity at infinite dilution. So when we are writing or comparing with the Mx plus C, that molar conductivity with respect to the square root of the concentration, so that should be the straight line like this way, and this is the intercept which is called molar conductivity at infinite dilution, which is highest when the concentration is 0. But for the weak electrolyte, it is not following the same pattern. It is following like that way, like this way. So this is for the strong and this for the weak electrolytes. So now one more scientist came whose name is Kohlrausch and considered as a Kohlrausch law. तो कोहराश लॉ ने यहाँ पे कैलकुलेशन दिया है वीक इलेक्ट्रोलाइट्स का, और भी एप्लीकेशंस दिए हुए हैं कोहराश ने. तो लेट अस अंडरस्टैंड कि कोहराश ने कहा क्या है. तो कोहराश क्या बोलते हैं कि एट इनफाइनाइट डाइल्यूशन व्हेन डिसोसिएशन इज 100%, ईच आयन मेक्स द कंट्रीब्यूशन टू द कंडक्टिविटी irrespective of the nature of the electrolytes. So we will write the molar conductivity at infinite dilution would be is equal to molar conductivity created by the cation, molar conductivity created by the anion, and N1 and N2 are their numbers. So N1 is representing the number of cations and N2 is representing number of anions. And this is happen at the infinite dilution. So in some books it is given like that way, that lambda they have used, lambda plus and the lambda minus. N1 and N2 is a number of cation and anion. This is the molar conductivity. So like for example, If we are writing the molar conductivity for NaCl, so we can write that NaCl is gonna be dissociated into Na plus and Cl minus. So N1 would be equal to 1 and N2 also would be equal to 1. So we can write that lambda Na plus at infinite dilution and Cl minus infinite dilution. Similarly, we can take another example of molar conductivity at infinite dilution for aluminium sulfate. So Al2SO4 whole thrice, that is giving us twice of aluminium plus 3 and 3 of sulfate. So total molar conductivity at infinite dilution would be is equal to twice of conductivity is done by the aluminium and the conductivity is done by the sulfate ion. In fact, by using the Kohlrausch law, हम equivalent conductivity भी निकाल सकते हैं. Equivalent conductivity, that equivalent conductivity of cation at infinite dilution and equivalent conductivity of anion at infinite dilution. So if suppose I need to calculate the equivalent conductivity of aluminium sulfate, then it should be the equivalent conductivity of the aluminium plus 3 plus equivalent conductivity of the sulfate ion. नंबर ऑफ आयंस को कैलकुलेट करने की ज़रूरत नहीं है क्योंकि इक्विवेलेंट मोल्स में उसका एन फैक्टर इन्वॉल्व ही रहता है. बट येस, सपोज इफ आई आस्क यू व्हाट इज़ द रिलेशन बिटवीन द इक्विवेलेंट टू द मोलर कंडक्टिविटी, तो हमें पता है मोलर कंडक्टिविटी वुड बी इज इक्वल टू इक्विवेलेंट कंडक्टिविटी इनटू एन फैक्टर. So molar conductivity would be is equal to equivalent conductivity for aluminium sulfate, that is the charge on cation, it's plus 3 या minus 2. तो n फैक्टर क्या होता है? टोटल चार्ज 3 इंटू 2 पर 6 का मल्टीप्लाई कर दो तो तुम्हारे पास आ जाएगा n फैक्टर 6 का. So here we can write, in this equation we can write the molar conductivity of aluminium sulfate by 6. अब अगर इस इक्विवेलेंट को भी अगर हमें कैलकुलेट करना है, सो व्हाट वी कैन डू, वी कैन राइट द सेम थिंग, दैट मोलर कंडक्टिविटी ऑफ एल्यूमिनियम प्लस 3 डिवाइड बाय द 3 एंड मोलर कंडक्टिविटी ऑफ सल्फेट आयन डिवाइड बाय 2. सो इससे हमारा आंसर आ जाएगा, दैट इज़ द मोलर कंडक्टिविटी ऑफ एल्यूमिनियम सल्फेट, 2 of molar conductivity of aluminium plus 3 and 3 of molar conductivity of the sulfate ion. So you can observe कि ये equation उससे मैच हो गई है. तो इस तरह से तुम रिलेशन निकाल सकते हो मोलर कंडक्टिविटी टू द इक्विवेलेंट कंडक्टिविटी. So based on Kohlrausch law we have a multiple application. So let's write application of Kohlrausch law. First one is calculate weak electrolyte conductivity by using strong electrolytes. तो जिसमें पहला क्वेश्चन के फॉर्म में ही करते हैं कि जैसे तुम्हें क्वेश्चन में HCl दिया है, NaCl दिया है और सोडियम एसीटेट दिया हुआ है. इसकी मोलर कंडक्टिविटी एट इनफाइनाइट डाइल्यूशन पर लेट्स से x दी हुई है, y दी हुई है, z दी हुई है, एंड दे आर आस्किंग फाइंड आउट द मोलर कंडक्टिविटी ऑफ एसिटिक एसिड. सो व्हाट वी कैन डू, सिंस ऑल 3 आर द स्ट्रॉन्ग इलेक्ट्रोलाइट, तो हम इसको H प्लस एंड Cl माइनस लिख सकते हैं, इसको Na प्लस एंड Cl माइनस लिख सकते हैं, इसको CH3CO माइनस एंड Na प्लस लिख सकते हैं. These many ions we will get it into the solution. अभी हमें मोलर कंडक्टिविटी ऑफ द एसिटिक एसिड निकालना है, मतलब CH3CO माइनस चाहिए और H प्लस चाहिए, हमें सिर्फ ये दोनों आयन चाहिए. नाउ व्हाट वी कैन डू, हम इनकी मोलर कंडक्टिविटी को कुछ इस तरह से मैनिपुलेट करें कि हमें सिर्फ 2 ही आयन्स सॉल्यूशन में मिलें. कौन सा? एसिटेट आयन एंड H प्लस आयन. सो व्हाट वी कैन डू, We need this one, so we'll put the here plus. We have to remove the sodium, so we will put the minus here. हमें इसको भी चाहिए तो हम इसको भी प्लस लगा देंगे. So based on that, ये प्लस Cl है वो माइनस Cl है, will get cancel. एंड ये माइनस सोडियम है, ये भी प्लस सोडियम है, ये कैंसिल हो जाएगा. एंड लास्ट में हमको बच रहा है एसीटेट आयोन एंड H प्लस आयोन. सो इट शोज दैट कि इसकी कंडक्टिविटी हो जाएगी X minus Y plus Z. That should be answer. So this is the first application of the Kohlrausch law, which is utilizing to calculate the conductivity of the weak electrolytes. Now we'll go for the second application. We can calculate the degree of dissociation of weak electrolytes. So that is defined as a alpha molar conductivity as C concentration by molar conductivity at infinite dilution. This is called the degree of dissociation. Apart from that, if you are taking a weak acid, so H plus and C minus, A minus, so C0, 0, C1 minus alpha, C alpha, C alpha based on the ionic equilibrium. So the dissociation constant for acid is become C alpha into C alpha, C1 minus alpha. You can cancel it out and you will get the C alpha square upon 1 minus alpha. So if the dissociation constant is very less, degree of dissociation is very less, then it should be C alpha square, and alpha you can put up here. So Ka value we can mark it. Molar conductivity at C concentration by molar conductivity at infinite dilution would be square. That also we can apply. Now third application we have solubility. Sparingly soluble salt. Sparingly soluble salt means which can form the saturated solution fast. So solubility is nothing but the molarity or molality. So we know that kappa is equal to, so we know that molar conductivity would be equal to kappa into 1000 by molarity. And this molarity we can represent as a solubility. So molarity would be is equal to kappa into 1000 by molar conductivity at infinite dilution or the C concentration. So if suppose we have a AB type salt, then we know that KSP value is S square, and where S value, this could be the S value, that should be equal to kappa into 1000 by molar conductivity. So we can calculate the solubility from here and we can put up over there to calculate the solubility product. The fourth application is a ionic mobility. So ionic mobility means it's a distance traveled by ion per second under potential gradient 1 volt per centimeter. So potential gradient is equal to volt per unit of length. So ionic mobility is represented by the mu. For the cations or anions we can go ahead, and that is the at infinite dilution the maximum ionic mobility we can observe, or else we can say the speed of ion at infinite dilution under the potential gradient. So we could write that is the speed of the ion divided by the volt per unit length. So that should be meter second inverse, and that should be the volt centimeter or meter inverse. So we have a unit also, that is the meter square, second inverse, and the volt inverse. So in general we can say the mobility is directly proportional to the size of ion. So like for example, if we have a lithium plus, Na plus, K plus, Rb plus and cesium plus, then mobility for the cesium is highest because of the hydrogen energy. Lithium has become so heavy. The same thing you can apply for the anions also. So bigger the size, higher the mobility. So lithium is moving very slow because of the hydration energy. It becomes so heavy and cannot move faster. So if suppose I draw the diagram of the molar conductivity with the concentration and asking you, that is the A line and this is the B line. So among these NaCl and KCl, which one is belongs to A and which one is belongs to B? So we can observe the B having the lesser molar conductivity compared to the A. So molar conductivity is directly proportional to the mobility of the ions. So here the KCl would be A and NaCl would be B. And here if I am adding the HCl, so hydrogen chloride is coming on the top because hydrogen mobility is high as due to the hydrogen bonding. And if suppose one more I am adding CH3COOH, it's a weak electrolyte, so this should be this one. Let me write this is C and this is D. So D is belongs to the acetic acid, C is belongs to the HCl, A is belongs to the KCl, and B is belongs to the NaCl. So this is about the Kohlrausch law and its application, which is belongs to the conduction part. सो थैंक यू टू स्टे कनेक्टेड विद मी। थर्ड लेक्चर जो इंक्लूड है वो है नस्ट इक्वेशन और उसके एप्लीकेशंस पर, बहुत ही इंपॉर्टेंट है नीट और जेई पॉइंट ऑफ व्यू से। स्टे कनेक्टेड एंड लाइक शेयर एंड सब्सक्राइब, get the good score and come out with the good result. Thank you.